A 0.1 kilogram solid rubber ball is attached to the end of a 0.8 meter length of light thread. The ball is swung in vertical circle as shown in the diagram above. Point P, the lowest point of the circle, is 0.2 meter above the floor. The speed of the ball at the top of the circle is 6 meters per second, and the total energy of the ball is kept constant. Determine the total energy of the ball using the floor as the 0 point for gravitational potential energy. Determine the speed of the ball at point P, the lowest point of the circle. Determine the tension in the thread at the top of the circle, at the bottom of the circle. Okay. And the ball only reaches the top of the circle once before the thread breaks when the ball is at the lowest point of the circle. Determine the horizontal distance that the ball travels before hitting the floor. Let us write down the data. Mass is 0.1 kilograms, radius is 0.8 meters, velocity is 6 meters per second, g is equal to 9.8 meters per second square. E total. Let us calculate the E total here at this point. At this point, the ball has both the kinetic energy and potential energy. And then the velocity, kinetic energy is equal to half mv squared and potential energy is mgh. And velocity is given to us as 6 meters per second. And then the height is given as 0.8 plus 0.8 plus 0.2, that is 1.8 meters. Therefore, the total energy of the system is 3.6 joules. Next, we have to calculate the energy at P. And then from there, we have to calculate the velocity at P. What we do is, we consider the law of conservation of energy. According to the law of conservation of energy, total energy of the system is conserved. So the energy at the top is equal to energy at P. Here we calculated the energy at the top as 3.6 joules, that is equal to the kinetic energy plus potential energy at P. At P, the ball has again both the kinetic energy and potential energy. So it is equal to half mv square plus mgh. 3.6 joules is equal to half mv square plus mgh. But h is equal to 0.2 meters, not the 1.8 meters, because this is the lowest point. This point is only 0.2 meters above the ground. Taking that one, plugging that value, we can calculate the velocity as 8.25 meters per second. Okay, this is the answer for the B bit. Next, C bit, he has two sub questions. He is asking us to find out the tension at the topmost point and at the bottommost point. So at the topmost point, both the tension and gravity are acting downwards, and they contribute to the centripetal force. Therefore, sigma Fy is equal to Ft plus Fg is equal to Fc. So Ft is equal to Fc minus Fg. If Fg is equal to mg, so 0.1 times 9.8 is equal to 0.98 newtons. Okay. And then Fc is equal to mv square over r is equal to 0.1 times 6 square divided by 0.8. At this point, the velocity is 6 meters per second. So I am taking that value and calculating the centripetal force. So while plugging in these values here, Ft is equal to 3.52 newtons. Now we have to calculate the tension at the bottommost point. Again, we will write the force equation. Here you see the free body diagram. The gravity is acting downwards and tension is acting towards the circle, towards the center of the circle. Therefore, the net force, the difference in the tension and gravity contribute to the centripetal force. Therefore, Ft minus Fg is equal to Fc. Now we have to calculate the Fc and Fg so that we can find out the Ft. So Fg is equal to 0.1 into 9.8, 0.98 newtons, and Fc is equal to mv square over r. Remember, here the velocity is different from the top point. We calculated this velocity as 8.25 meters per second, that we have to plug in here to calculate the Fc. Okay, so that is equal to, when we plug in that value, we get that as 8.51 newtons. And then, therefore, Ft is equal to Fc plus Fg gives the value 9.49 newtons. 8.51 plus 0.98 is equal to 9.49 newtons. Next, last bit. According to the question, the ball completes only one full circle. After that, the thread breaks when the ball is at the lowest point. When the ball is at this point, the thread breaks. So the ball has to drop only 0.2 meters. Okay. So here the ball acts as a projectile falling under the free fall. Okay. Gravity is the only force acting on the ball. Once the thread breaks, so we will calculate the time taken by the ball to reach drop 0.2 meters or to reach the ground. So that we will calculate using the kinematic equation delta y is equal to VA by t plus half AT square. Here the velocity along the vertical direction, vertical component velocity is 0, and then acceleration is 9.8 because it is under the free fall. And then delta y, that means the distance that the ball has to drop is only 0.2 meters, and it is downward direction, that is why it is the negative sign. Using these values, we will calculate t as 0.2 seconds. Next, horizontal displacement is equal to horizontal velocity times t. Here we already calculated the velocity. This velocity is the horizontal velocity because the vertical component of the velocity is 0, the point where the thread breaks. So this velocity times the time gives the horizontal displacement. So plug in the values, you get the value delta x is equal to 1.65 meters. Okay, this is the answer for this question. Hope this helps. Thank you. Bye bye.